All right, welcome back, everyone. Thank you very much, and thanks again to the folks at Elemental for this morning, the first session. So next up, we've got a great session for you. How many people here are fans of Adult Swim? Yeah, there we go. So
CNN.
Oh, CNN too, yes. So we've got Michael Cutter, who is the VP of Media Services at Turner, and Moosman Shaquille, who's our principal technologist for media and entertainment. They're going to talk through a little bit of Turner's migration and adoption and embrace of the cloud. So we've got some great stuff coming. Gentlemen?
Thank you, Ian. Good afternoon, everyone. My name is Moosman Shaquille, and I'm a worldwide tech leader for media and entertainment at Amazon Web Services. And along with me here is Michael Cutter. He's the VP for Digital Media Systems at Turner. So the story we're going to tell you today, it started maybe a year and a half ago, something like that, in a conference room. Michael said, hey guys, we want to do this. How can we do this? And you know, AWS is an infrastructure provider in the cloud, and we really focus on infrastructure as services. While we've built some specialization in media and entertainment and other industry segments, you know, can't really compete with Michael. So it went back to you know, that customer obsession. That's one of our key leadership principles within Amazon. That, you know, we really appreciate, Michael, if you could tell us, guide us, what are you looking for, and how can we go and build it together? How can we partner together and go build it? So we work together, you know, multiple set of conferences, meetings, and whatnot, working with different technology providers, partners, etc. And here we are, talking about a workload that is actually in production. And I'm really excited to talk about it today. So very quickly, the way we're going to work on this is, or we're going to deliver the content here is, I'll go through, you know, the concept of media supply chain or the whole workload itself, some of the appropriate AWS services, best practices, and you know, the upcoming things that could be relevant. And from there, I'll hand it over to Michael, and he'll talk about, you know, where they were, where they want to be, what their vision is, and actually the technical details of how they implemented their cloud-native content supply chain for TNT, TBS, Adult Swim, Cartoon Network, and CNN. So just a quick show of hands, how many of you actually attended the session right before this one, the Elemental session? All right, cool. Decent majority of people, that's great. Kawaja and Dustin did a great job in terms of talking about you know, some of the similar concepts that we're going to talk about here. And the reason I asked is, you know, based on that, I'll kind of gauge myself how to kind of, how much to deep dive and how much is already covered. So we heard a lot in terms of depth with respect to the simple queuing service, with respect to the VOD workflows, with respect to Amazon S3, and actually going into the live scenarios as well, you know, how you can use some of the services like Amazon S3, the object store, et cetera, for live, et cetera, as well as VOD. Now, this specifically is, topic is very similar in terms of the VOD specific workloads, because if you look at it, it's all file-based. Right? How the file comes in, how the different aspects of the media or content supply chain are applied to it, and then we move on from there from a delivery aspect. So before we get into it, let's very quickly recap how AWS, Media and Entertainment organization, looks at the media segments. So this is totally based on what our customers have told us. Right? Starting from the acquisition of the content, to storage of the content, the archive itself, the asset management systems, various production and post-production type of activities like visual effects and editing, to digital supply chains that we're going to talk about in this particular session. And then moving on to delivery, from over-the-top delivery to channel playout and distribution, as well as publishing, and to tie the whole circle together, analytics. So we have customers across the M&E industry segment that are doing either bits and pieces of different workflows that are depicted here. And actually, it is working with these customers that have really educated us to put this thing in place that, this is what we consider as the media all-in for our customers. And in this M&E pre-day track, what we also try to do is really showcase the different segments within the M&E industry here. So earlier you heard from Dustin and Kawaja about over-the-top streaming type of scenarios, as well as some of the video processing type of workloads, right? We're going to talk about digital supply chain here. Later on, after our session, there is a session with Discovery to talk about their channel playout. And then the last session in the M&E track is going to be around some of the production and post-production tools in the cloud. So we try to make it, throughout to cover all the different aspects of the M&E media segments. So a few key evolutions in our industry. So, you guys have probably seen these graphs several times in different conferences, articles, blog posts, etc. But there are three key things that I like to point out here, right? Why move to the cloud? When we talk about this whole thing, there is an evolution of customers asking to move to the cloud for their core media entertainment workloads. Why? Why is that? And there are three key drivers for that. First of all, and the most, I would say the biggest one, the technology disruptors, or the newcomers I like to call them. The Netflix, the Amazon Videos of the world, right? There is a huge trend in terms of the direct B2C, direct to consumer, the OTT space, the digital space. We can see the growth in terms of the number of Netflix subscribers, right? The whole phenomenon around cord cutting and the millennials. We see Stars offering cheap new streaming service of their own, BBC doing the same thing. There are many other examples along those lines. And what we also see is that it's not just the B2C phenomenon, it's also knowing the customer, the consumer. What does my consumer want to watch? There is so much content available out there. I mean, heck, I sit down about to watch TV late night. Well, where do I start? What do I go watch, right? It's really those first few minutes that these media folks will have to capture my attention as a consumer, right? If they are successful in doing that, then they're successful in selling to me. So they need to know who I am as a consumer, right? What type of content I would like to watch, that I would spend, the valuable time that I have watching that piece of content. So what we see is this sort of move towards analytics, not just in the recommendation space or in the search or searchability space, but also moving all the way towards the production decisions. What do I need to do in order to find out what type of content I should really go and invest in? So that's a new area. Then there is a huge cost crunch. We know that with these newcomers or really technically advanced companies coming into the picture, the traditional model of media production, media storage, media supply chain, all the way to media delivery is evolving quite rapidly in terms of how can we really not only cut in terms of cost, but also the pay-as-you-go type of model. I don't have to be really stuck with an existing infrastructure. Rather, I can expand, I can grow based on the needs. And then content obviously has gravity, and it's getting heavier and heavier. We know the 4K, 8K phenomenon and beyond, and these content files are really growing. And it's not just that the content resolution, that the files are growing, but also the selection is growing. That's the key aspect there. So when you put all these things into perspective, that really begs the question that what is the new normal? And as we've heard from many of our customers, that this sort of interest or this sort of requirement to move all in the cloud. And how we define that all into the cloud is really this workflow that starts from content acquisition to content storage, asset management, searchability, post-production, production, media supply chain, and various delivery aspects of the media workload. So then the second question is, where do I begin? Right? I mean, it's a pretty complex value proposition, it's a pretty complex workload at the end of the day. Even the sub-workloads within this end-to-end theme is quite complicated. So picking it all up and moving it into the cloud, is that really workable? Do we really preach that? No. The reason for that is there is a lot of advancements in terms of technology. There's a lot you can really leverage in the form of managed services from features perspective to really optimize your workflow. And this is the opportunity for you to take your workloads and look at them piecemeal and say, how can I take different aspects of it and what is cloud ready and what I can move into the cloud? So a great customer of mine actually said, you know, there is hardly any workload in the media space actually that you cannot move to the cloud. And if a vendor or say a software vendor tells you that, you know, that we can't move this workload to the cloud yet, don't take no for an answer. Just say, how can we move this? How can we work together to move this into the cloud? Yes, you will have to optimize your workflow. You'll have to optimize your application, how it runs on a physical bare metal infrastructure versus a virtualized environment on the public cloud, but it is all possible. So where do we begin? First of all, decoupling. Decouple your all-in workflow. Take a look at it. Where can I start? Every business has different requirements. Every business has slightly different variations of this end-to-end workflow. So take a look at it, decouple different aspects of it, and see what is readily available and what are the things that need to be optimized. And we work with you, with our partners, with different software vendors in the media space to make it a possibility in the public cloud. Secondly, microservices. And Michael will talk about it in a great depth of how it really helped in their migration of their media supply chains into the cloud. And it's really, at the end of the day, it's not really a buzzword. You know, there are a lot of advantages that you will see, and as we'll talk about, specifically from being, you know, specific scope. Like earlier I mentioned, you know, the whole idea around not having to specifically get set with a specific type of infrastructure, rather have the flexibility, the scalability aspect of it, right? And this is where microservices really help you. That even within the cloud pay-as-you-go model, you don't have to get stuck to a specific type of an instance or instances, right? Rather, you can have these set of microservices that are daisy-chained together in the form of a workflow and enabling this capability for you to run these individual services in a specific scope. And these are all interoperable. And they also allow for rapid innovation. And again, Michael will talk about in much more depth, you know, how this is all relevant in their workload. So let's shift gears and talk about media supply chains, right? When we talk about media supply chains, I consider it as the core backbone of your media and media business. So if you look at it, you know, an inside-out view, if you will, in the center there is the digital supply chain, and then you see all these ancillary workloads that are kind of hanging off of it. So media supply chain could be in the case of production, post-production type of scenarios, or it could be in the case of broadcast or delivery kind of scenarios. So again, you know, different businesses have different requirements. But what you'll see is that these workloads, whether in the production space or the broadcast space, they do share a lot of commonalities. Commonalities from the aspect of the ingestion piece is about the same, right? How do you manage these orders? The scale of that is going to be about the same. Then there is the quality check aspect of it, right? How do you run the QC? Yes, you're going to have different configurations, different requirements around QC, but at the macro level, the distributed processing is the same. The transcoding aspect, the metadata extraction aspect, the searchability aspect, and so on and so forth. All in all, it's a highly complicated workflow. But once you have it migrated, optimized and migrated into the cloud, then you can see there is a whole lot of opportunities to move other workflows into the cloud as well, whether that be content acquisition in the case of live or file-based content acquisition, or digital asset management systems or archive systems like active archives, your golden copy or your raw masters, or your preservation type of workloads, whether that be production or post-production type of activities, things like editorials, dailies, social media, marketing promos, anything like that. Because now your supply chain lives in the cloud and it accesses a content library that also lives in the cloud, and you have all these aspects that you can take one by one and start moving into the cloud. On the distribution side, again, the output of your media supply chain comprises of the input to all these different workloads that you see on the right-hand side, whether that be live TV in the case of playout and distribution, and you're going to hear about this from Discovery later in the afternoon, specifically how they take their media supply chain, build it in the cloud, and how does that enable them to broadcast or originate their channels from the cloud. If we want to talk about OTT, specifically live to VOD, different flavors of VOD, catch-up TV, your cloud PVR, etc. Again, your content lives in the cloud, whether you make one copy or you make a copy per subscriber, how you DRM it, how do you deliver it, all those aspects could be really tied into this workflow, and that gives you sort of this OTT solution. Publishing, very similar. Again, your content is here. If you need to go create some clips, edits out of the content that's in your media supply chain already running in the cloud, then it's easy. Then you can simply publish it into your digital properties as well. And then finally, your B2B cinematic delivery or B2B delivery for affiliates. If you want to deliver in multiple different formats, packages, we'll talk about the complexity around that, like DPP or IMF or NABA. But the point being that anything that you want to deliver, since the content lives in the cloud, you can use the agility and flexibility of the cloud compute models along with microservices to get to a destination workload that you want to. So that is really the cloud-enabled domino effect. So this is actually a drawing from the ETC DI workflow for major studios. This is actual as told. And as you can see, there is, what we tried to depict is to take this workflow and kind of, put different AWS services, or how you will use different AWS services to accomplish this. So a simplified version of it, really you have your content coming into an S3 bucket, or say your object store. And it could be, you can import mastered content along with metadata into S3. Kawaja earlier talked about, details around the best practices and services you can leverage from AWS, things like AWS Direct Connect or Snowball, or even S3 accelerated transfer, S3 multi-part upload. And then there are tons of partner solutions, things like Aspera, Signient, many others that give you the capability to transfer content into S3. This is a kind of a model where you see what you leverage today in your on-premises storage to get this content in from your vendors. The same kind of principles apply, the same kind of tool set apply. It just has to be adopted to work on the cloud. The second piece is, quality check. So sometimes we see that there is an automated QC process that happens in the cloud that could be built as microservices or a batch service, where basically a piece of content landing in S3 triggering a Lambda function or a notification that triggers a Lambda function that spawns off a QC job. So the idea being all of a sudden, you don't have to have a infrastructure cluster running, say your servers, QC servers running all the time, waiting for the files to come in. Rather, it's on demand. As the file lands in S3, it triggers a notification that triggers a Lambda function that triggers a QC job that says yes or no, and then from there on, it moves on or takes a path. That could be create, edit, collaborate in the cloud, or it could be master, version, package, a lot of different aspects of it. And then from there on, you go to the distribution step, which is distributing the content to play out, to OTT or other cinematic production. So here we see at a very, very high level, what are the different steps and how you can leverage different cloud services for that. Some macro level ideas, highlights, again, Kawaja and Dustin did a great job kind of talking about this in depth, and I won't go in a whole lot of depth here, but a few highlights here. So, watch out for the announcements throughout re:Invent, new EC2 instances. We're really pushing the envelope in terms of the different specifications from a core memory perspective, from a high I/O network performance perspective, and really some of these workloads that weren't possible in the cloud because, hey, there was a specific GPU requirement, or there was a specific core to memory requirement, or a low latency I/O kind of a requirement. It's hard to believe that we've come a long way in such a short period of time. And you have to look at specifically what is the underlying application or workload characteristic, and then jump into, okay, this is the appropriate selection for that. And we help you come to that or accomplish that. Cloud storage is an area where we are working very closely with some of the large or major Hollywood studios, as well as globally with broadcasters, to kind of understand the requirements. So as you know, that there was the Amazon S3, the very first Amazon AWS storage service that we had. Then we got into Glacier. Then from Glacier, we got into S3 infrequent access. And just recently, we announced a couple of new retrieval tiers for Amazon Glacier. And if you look at the characteristics of all these different tiers, they kind of map very nicely back to the requirements that we've been hearing from our media and entertainment customers. So like a studio or like a broadcaster, they have a pretty large archive, for example, right? And from that archive, there's millions of files that are available. Now, should I be paying for the S3 standard for that, when I don't really need to have access to every single one of them? But if there is a breaking news event, then I need to go and get access to some of these files very, very quickly. So how do these sort of, say, transitions happen, in between storage tiers, et cetera? And we're really trying at AWS, our storage teams are really hard at work trying to take care of that gap, right? So that from a customer perspective, it doesn't matter where your content lives. Choose the storage which is most cost effective to you, and from a performance perspective, that comes to you on demand. So that's really the principle behind what you will see with the new storage offerings. And we're doing a lot from a pricing perspective, right? Based on how can we meet the needs of our customer based on-premises versus in the cloud. Amazon Elastic File System, that's a shared file system that we launched last year, and now it's in general availability. We've seen some great results, some great outcomes from some of our media entertainment customers, specifically in media supply chain use case. Again, the principle there is try not to move the content back and forth, even within the cloud, from S3 to EBS and back, and so on and so forth. Try to consolidate it in one storage location that all your processes kind of consume from. And that's really the principle behind Amazon EFS. And for you guys, if some of you have tried it, we've seen some great performances out of it. In fact, last year I gave a session on it about the performance of EFS. On Elastic Block Store side, we've launched new volume types that are a couple of them that are targeted towards these specific use cases. So one of them being the throughput optimized and the other one being capacity optimized. So again, the idea being if you are running a process-heavy workflow, which is say your media supply chain for transcoding, etc., you can use the throughput optimized volumes. And if you have it as say a cold archive, which you need a lot of capacity at a pretty cheap price, but you want to have it available, accessible to you over a file system, then that's a great way to do that. Nonlinear editing in the cloud, we've heard loud and clear from our customers. There's a lot we're doing there in that space, specifically from a GPU perspective, from a Amazon Workspaces launch, graphics workspaces, that's a step in that direction, and there is still more to come. And then microservices, serverless, you see AWS Lambda and Amazon API Gateway, and we'll hear a lot from Michael with respect to that. So with that, I will hand it over to Michael to talk about media supply chains at Turner.
All right, cool. Hey, everyone. So a little bit about me. I've got a pretty broad role at Turner that goes from content creation systems for news and sports, all the recording and editing and playout systems that we use to produce CNN and NBA and other live products for Turner. Content supply chain that I'll talk about today, but also the technology infrastructure that's the underpinning of all of our broadcast equipment that we use at Turner. So that's kind of an interesting role because we're starting to move some of that into the cloud. And before I get into my deck though, I just thought it'd be cool to show you a little bit about what Turner is doing these days in terms of content and what type of content we're moving through the system. Hit the video.
Everything's a gamble. Lights could go out. The sun could fall out of the sky tomorrow. The best advice is never to do anything. You'll never get in trouble if you don't do anything. But on the other hand, you'll never get anywhere either. You know.
Miss for $1, name 3 Clintons.
Kennedy.
Get out of here!
Oh my God, Morty, what did you do? You killed the Simpsons, Morty. Oh God, look at the baby one. Oh my God, Morty.
Keep going. Don't mind me.
How do you fly a 767?
Plane, James Taylor, you've got a friend.
No!
Nope, not doing that.
For all the things my eyes have seen, the best by far is you. If I could.
Sounds like we're about to make some memories.
Go on.
Good content. Hustle all day long.
You spell fun, W-I-N.
And you're the sky.
All right. So it's some pretty cool content that we're moving around Turner right now. We're doing more things with that content than we ever have before. And so kind of from a top level perspective, we're leading the media industry's transformation through our approach to technology, data science, and innovation. But specifically, when we look at our end-to-end media supply chain, and that's sort of the topic of this discussion, we're connecting content producers with content monetization platforms to drive Turner's business across all of our brands, all of our networks, and all of our products. You guys saw this picture from Moosman. It's the ETC view of the sort of end-to-end supply chain for Hollywood. Here's the Turner view of that. We've got content suppliers with too many studios to even list. I mean, there's a handful of studios there on the left. There are just hundreds and hundreds of content suppliers that we work with on a daily basis. There's all of the outputs that you see on the right side, from pay TV to subscription video on demand, electronic sell-through, broadcast, broadband, direct-to-consumer, connected devices. We have to be able to get the content to all of those different environments, all of which have a different set of requirements. And so everything in between those two lines is what we consider our content supply chain. And so you see a few business systems at the top. There's our title system, which manages the top-level title metadata for every one of those shows that we saw just now. Our rights management system, which we've been working really hard to get out of the hands of a small number of lawyers who you pick up the phone and say, hey, do I have rights to this, right? To make it a machine-readable, computer-automatable process for discovering what rights we have for every piece of content that we hold. There's our ordering system, which I'll talk a lot about today, which is the way that any person or any system can request a piece of content be moved from one state to another state. And then our scheduling system that determines when content is going to be available, either in a linear broadcast or available on a digital VOD platform. Below that is our cloud media processing tier. And that's where we have Amazon and all of the infrastructure they provide, as well as our key partner, SDVI, who helps us to manage that infrastructure. And then from there, we move through to linear origination, as well as our on-demand content encoding pipelines. So that's supply chain. So just to give you a feel for what our just regular run rate is, it's a couple thousand items a month. It's big, but it's not crazy. It's pretty doable. We can build an infrastructure that can do this and can do it every day with absolutely no problem. And to be honest, we don't even need the cloud to do that. We've done this for many years. But here's where it gets tricky. We have things like Filmstruck, the Turner Classic Movies direct-to-consumer product that just launched. And we had a very short amount of time to get around 1,400 movies, as well as all of their ancillary bonus content processed through our systems and available for the consumer launch date for Filmstruck. And our on-prem systems are not scaled to handle things this way. As a matter of fact, our friends at CNN had to loan a very large transcoding farm to our friends at Entertainment to actually get these movies processed in time. So we really struggled to do this, and I got some of my team on the front row that are the ones that had to bear a lot of that brunt. So there's other things like subscription video on demand. Here's a Hulu logo, but it could be Amazon Video, Google Play. I mean, you name the subscription video on demand product, and there's always an initial load. It's when we first do the deal with that platform, they say, hey, we need 5,000 titles in a month to be up on this to meet the terms of this deal. And it changes with every deal, but all I know is it comes up fast and we have to process this stuff fast. And then there's things like promo production. You don't think of this, how difficult this is, but let's say that we're launching Powerpuff Girls, a new season in a new market internationally, and we hire a digital ad agency to do promos for us. And they say, well, that's great. Why don't you just go ahead and get all your Powerpuff Girl assets to us so we can cut those promos? And we're like, that's 1,000 items. What format do you need it in? When do you need that? So this is really peaky, elastic type needs. And this is where we're really putting pressure on the way we've done things in the past. So really what we need to be able to meet the future needs is a huge amount of flexibility, right? Because every supplier is different. I'll just give you one example. We may have content that's coming in from something like WB. And we say, well, great, how are you going to deliver it to us? And they say, well, we've got these masters and they're 29.97 frames per second, but they used to be 24 frames per second. And we want to process it from the original native frame rate. We will have to go in there and remove frames that were created during the 3.2 pull-down process. So there's all kinds of different types of processing that come on for all the inputs. And then you saw how many different types of outputs. The Netflix requirements are very different from broadcast, or very different from iTunes. So we've got to have a huge amount of flexibility. And with that flexibility comes agility. Because in years past, people would do these deals and they'd say, hey, you've got, okay, great, we'll need that up in 6 months or in a year, right? You know, these things are coming up and we have to turn them around in weeks. It's kind of unheard of. I'll jump to the right. There's elasticity. I talked about that. These content processing things are very peaky. We don't know what we're going to have and how long we're going to need to process it. But maybe the most important thing, and I almost left this off the list, and somebody on my team told me, you can't leave off analytics because that is the secret sauce that's really going to help us to be more efficient and more productive using this technology in the long run. So these are I think the top 3 things that we're looking to get out of our next gen supply chain. And so we kind of break this down into a couple key areas. There's the idea of the processing that we need to do and the orchestration layer that needs to control that. It's kind of the brains behind the operation. And then all of the media microservices, the tiny fine-grained bits of capability that we need to chain together into unique and novel flows to suit any of these scenarios. And so if we zoom that out just a little bit, we get this. So this is a sort of a block diagram for our supply chain. And the top is that flexible process engine. We call it our work order management system. And this is sort of content tracking and flow control. This is the place where any system can call it via an API and say, I need this content to go from here to here, or a user can log in and create those content orders. Then below that, you see some of the microservices. This is dramatically simplified, but there's obviously the upload service. So we got to get it from our supplier up into the cloud. There's auto QC. One of the key things that we're about this is the ability to keep the content in the cloud and not have to move it down all the time. We don't want somebody in an on-prem quality control environment to have to download the master quality video every time we have something come through the supply chain. So automating that video and audio analysis allows us to figure out where things fail and why they fail. And only in some scenarios do we think we're going to have to pull that video down and have a closer look. There's input processing. I talked a little bit about that's the normalization of the incoming video from all of the different formats that we support from our suppliers. We do have specifications, but you know the industry is pretty slow to change, and I think for the immediate future we're still going to accept QuickTime. We're still going to accept MXF. We'll have DNX and ProRes and MPEG and a number of other formats that our partners know how to create. So we normalize that into a single format when we bring it through our input processing. The mastering stage is where we take that, what you could sort of think of as like a blob. I mean, a video file is just a video file and a bunch of stuff is crammed in it. That's not the way we want to think about that. We need to parse it out into structured data, where each one of those audio files and each one of those text tracks and each one of those video tracks is an object in Amazon's storage environment. And so now we can take those objects in that cloud library and put them back together again with specific recipes for the right pieces in our versioning system. Hand that to output processing for the final distribution ready encode, and then deliver it off to wherever it needs to go. So that's the big picture perspective on that. I'm going to talk more about the left-hand side of this diagram as we go through the deck, and really our receiving process and how we handle that. So if you look at our process engine, we've kind of broken it down into a couple areas. There's the order types and the order core. we need to be able to really quickly create lots of new kinds of workflows. We call those order types. By abstracting the ability to quickly create those order types, we can create a rapid development environment. We call it workflow on Rails. So we can create that simplified environment with lots of helper classes so that we can have a team that can focus on technology like JavaScript and Python and higher level coding to be able to rip through these things and move very flexibly and quickly, while the order core is a fully abstracted and instanceless implementation of all of our business logic and all of the core systems that keep the workflows running and that are common to all workflow types. So a little more on this. So on the order type side, we have a command line order scaffold generator. So you can go in and tell the system all about your workflow. You know, what are the states in your workflow? What is the form data that's required by your workflow? What are the rules that are in your workflow and decisions that have to be made when various data types are true? Feed that into the scaffold and it creates the basic workflow. And then you can customize the HTML template and customize the form data to get exactly the screen flow and the technical process management that you need to be happening behind the scenes. If you look at the order core, that's where the state machine lives. That's where our resource allocation system lives. Resource allocation, you guys know what a state machine is. Resource allocation is the thing that helps us to identify the cost of a transaction in the cloud at the content minute level, and to be able to associate that cost with a step in the state machine. This is very important because from a business perspective, we've almost never had cost transparency into what it costs to process an item. So if somebody did want to go do a big subscription video on demand deal and we had to buy $2 million of capital equipment to scale up our transcode farm, think about how difficult it probably was for them from a business modeling perspective to figure out whether they were profitable on that deal by the time they did all the forensics accounting through all of the support contracts and all the people that we had to hire and all this other stuff. So resource allocation gives us really at the content item level how much it costs to push content through the goose. There's the rules engine, which is the thing that's constantly evaluating the environment and making decisions to make changes in the state or to send messages to other systems. There's our document database, which holds all of, we tip pretty much a NoSQL environment, and a lot of the stuff is either stored as JSON documents on S3 or it's pushed into Dynamo DB. And there's our UI shared widgets. So they're the shared UI functions that occur over and over again that can be used by multiple order types. So that's kind of how we broke it down. I think one of the more interesting things in this was as we looked at the cloud and thought, well, okay, we're developing an application directly on the cloud. We didn't want to just like install a J2EE server and then do what we would have done in the past and create a whole bunch of Java classes up there and use all of the inherent capabilities of Java to create a business logic tier. So we said, how would you build this? And we're like, well, we could host some Node containers up there and write a bunch of JavaScript. But we kind of made a bold choice and decided to make the order core instanceless. And in that respect, if you guys are familiar with Lambda, 100% of the business logic functionality of the order core is implemented in Lambda. And as such, we have very simple implementation, which is great because, and this kind of goes into our agile coding practices, typically infrastructure is a blocker. It creates friction for developers. And by using Lambda, it allowed us to sidestep that idea of creating infrastructure. We still create plenty of Amazon infrastructure, but we create a lot less by using Lambda. And we can get into a productive development environment, reference environment, production environment a lot easier. It's highly available without clustering. We spend a lot of time thinking about uptime. We worry about it constantly. And we spend a lot of time architecting, implementing uptime, and in this case, we have availability as a service. We just really don't have to think about it hardly at all. As long as the US East is functioning normally, we're all good. These guys will take care of that. It's scalable on demand. This is pretty awesome. So it does not matter how much code we need to run. We're going to be able to get access to as much Lambda resource as we need. And it's literally zero effort to administrate Lambda. So there's a lot of upsides to going Lambda. This is a picture of the actual application itself, the content processing application. And you can see right here that we're processing a What's New Scooby-Doo episode. And up at the top, there's a few workflow states that the state machine is keeping track of. Those green circles there, you see a little title information we got. And then you see the detailed step states that the state machine is working its way through on the right-hand side. And so a little bit more about those step states. So these are implemented 100% in JavaScript. And so we get the semantic richness of JavaScript to be able to create as complicated of a state machine as we need to for a particular workflow. That means if we need Boolean operations, we need decision making, we need to call out to other systems to be able to determine what the next step is, we can really code all of that into our JavaScript JSON file that runs inside the state machine. And you can see here that there's some pretty simple sort of waiting for content receipt, processing content, problem detected, et cetera. But again, this can be as arbitrarily complex as we need it to be. Then there's the rules engine itself, and here you can see the test harness that we call the order rules executor that we can use to basically run through all of the states and execute the rules throughout. So the rules are looking for things like, have we received a message from an external system telling it's completed a job? Or has a form element changed value such that it would cause me to make a decision to change a state in the state machine? And again, the rules are written in JavaScript, so they can be, again, as complex as we need them to be or as simple as we need them to be. And the only language that the people that are creating order types that include the states, the rules, et cetera, need to know really is JavaScript, and we can get through this whole thing. And here's a high-level sort of component diagram of the application. And just a couple of things to call out. One is that the actual web app itself is hosted inside our firewall off of our web servers inside of Turner, and that those web servers call out to the Amazon API gateway that gives them access to the Lambda functions that are running in the cloud. I think that this is kind of interesting in that we're hosting it across multiple completely distinct network segments. Within the cloud, all of those Lambdas interact directly with Dynamo DB, as well as with our messaging layer that allows us to communicate with external systems like SDVI. I'll talk a little bit more about SDVI in a minute. But one thing, just to take a step back and look at this, when we thought about this, we think about this as an application development platform and a set of associated APIs. I remember years ago we built an in-house media asset management system. We selected J2EE, and we went crazy trying to find the right container to run it in. And finally we picked Glassfish because it was the reference J2EE implementation. And for all that we struggled with that, we never even thought about migrating it to another container. And over the years, as the business kept moving on, we have slowly been refactoring that application into Scala and Erlang and JavaScript and other environments. And that's just what we do, right? These applications aren't static. They have to be continually migrated and moved over time to be able to provide capability to the business. And so when we thought, should we abstract from this API? We really just think of it the same way. Did we abstract ourselves from Java? No, we embraced Java. We used it to accelerate our development and use the core Java services to bring capability to our applications. And we're doing the same thing in this context. Okay, so back to this diagram. I'm going to switch gears and talk a little bit about the microservices themselves. So the first thing that we wanted in these microservices were for them to be dynamically created, right? We didn't want to be constantly consuming cloud CPU processes with stuff that's just running up there all the time and we're feeding jobs to it. It needed to be created based on the need to process. We also wanted our metering to be based on content minute. This is important because if we meter based on EC2 usage or S3 usage, it's good because we get an infrastructure perspective on how we're spending our money, but the business then doesn't understand exactly how much it costs to put that Scooby-Doo episode through the supply chain, which is what we're trying to give, is that cost transparency. So usage-based licensing is a really important part of this, and we needed for all of the compute, all of the infrastructure services, as well as the industry-specific software that we were running in that context, whether it's transcode or QC or what have you, to be bundled up into that minute-by-minute license. We also wanted media-aware analytics and optimization. So again, we could say, well, look, you process this many items from this format to this format. You could have done that more cheaply if you had made some different decisions. We get those analytics out of systems like Cloud Health that we use at the infrastructure layer, but again, we're trying to lift that up and look at those analytics at the media layer. And then the final thing is something that I think that we've begun to experience since we got into this environment is we want as fine-grained media services as possible. In the on-prem world, it's very common for a company to be able to just say, hey, look, we do it all, right? We can QC the video, we can transcode it, we can do caption alignment, we can do audio normalization. We'll do it all inside our environment. We'll give you a nice workflow engine inside it as well. I think once you get into a cloud environment, you realize that you really can have best-in-class, fine-grained services that do media processing. So if there's one company that has the very best algorithm for doing frame rate conversion, right? Great. Put it up there and let us consume it as a service. If there's a company that's really good at doing simple detection of misalignment of captions, that's great. Put it up there. We'd love to consume it as a microservice. What we don't want to do is feed this thing into like a gigantic honking, like vertically scaled monolithic process that does the whole thing, right? And that's not modular and it doesn't give us the flexibility that we desired. So that's the idea with microservices. Here's a few of the companies that we're using today. If you don't know the one icon with the bars, that's media info. That's just our upfront sniff test on media to make sure it's the right file format. We use Intera Baton for QC. We move files with Aspera. We do a lot of transcoding with Vantage. Also FFmpeg and Elemental all play roles in there. And this portfolio is filling out even faster since I did this, created the presentation. Here's what the workflow looks like. So a supplier comes in and they upload their content through our order portal, and at the same time they upload content into the S3 bucket. The S3 bucket triggers a SNS notification as a rule in that bucket, and it goes up and it notifies, and a Lambda, which is running on a cron, watches that queue, and when it sees that we've gotten the metadata and the content, it says, hey, it's time to kick off our processing workflows. We update our state machine so our customers in the order management app know what's going on. And then we kick off messages to SDVI via SNS. SDVI looks at what processing needs to be done, spins up the EC2 instances, and starts going through each of the step states, reporting status back through SNS, through the Lambda, back into Dynamo DB, so that we know what the process looks like in that domain. And then finally, when all that's done, it marks our order as completed, and we can notify other systems at Turner that that content is available. If you zoom out a little bit, This is what you see. And I sort of covered a lot of this already. I guess the one thing that I would say in this particular situation is you really can't see the central role that Lambda and SNS play as connective tissue for almost all of these processes. So some implications. One was security. A lot of you are probably thinking, gosh, wow, put all my content in the cloud. Well, our traditional on-prem security model has been perimeter-based, and perimeters can be breached. The risk domains are very large. Logging's not always robust, so because we were able to implement aggressive security in the cloud, our information security office was favorable to this move. And so we have separate AWS accounts for content storage with limited employee access. Employees can get into our on-prem storage all over the place, right? But we can provide very limited access here. We can limit access to S3 buckets with bucket policies that limit gets and puts based on VPC endpoints. We can create time-limited tokens for people to temporarily gain access to that high-quality content. Those time out, they no longer have access. We've got bucket logging in AWS CloudTrail, so we can see exactly who's touching that content. And then further to that, we can cache that content at Turner's Edge just for the content we need to reduce our data out implications. I got one other topic I want to talk about, and this is continuous delivery. It's interesting. The media industry is in the middle of huge changes. Huge! But if you look internally at the way that we operate, most people in our company are very averse to change. They don't like it. They don't like it because they perceive change as a thing that breaks things, and they know change will have impact in the way that they run their operations. So set it and forget it is like held as the ideal. They're like, hey, great, man, I put this piece of equipment in 15 years ago and it's still running. You know, that's the ideal way of thinking. So we put changes in infrequently. We wait until the middle of the night, the crickets are chirping, there's hardly anyone watching, you know, and then we push out a ton of changes and invariably something breaks. So if the business wants agility and flexibility, we need to change our delivery model and move to true continuous delivery, which means we automate the daily release process. And I will just say right now, we already do this. The whole UI framework that is where new features touch our users the most is on a daily deployment, automated daily deployment now. You have to take action if you don't want it to deploy. One of the greatest days of my life was when we missed a few daily deployments and our customers got really upset and they said, oh my God, that's going to be a whole lot of features in one deploy. That might break something. That was awesome. So we want to reduce bit rot. So when code sits on the shelf, it gets old and defects creep into it as things change around it. And we want to improve developer productivity. We want to release in smaller increments and control risk and deliver faster value to the business. So how do we do that? On-prem, it's Jenkins and Chef doing a daily deploy on a schedule. In the cloud, we've created completely different code pipelines for our stateless infrastructure and our stateful infrastructure. So stateless is completely automated through CloudFormation, Jenkins, and Gradle. I would anticipate at some point we probably would put some of that stuff on a scheduled deploy as well. This is fairly new. And then the actual infrastructure itself is all CloudFormation and automated. But the great thing is, from the infrastructure all through up every tier of the application, it's completely automated deployment and configuration management. It's really, really exciting. Okay, so a few challenges that we've overcome. One of the really crazy things was we started developing Lambda and we're like, wow, this is hard to debug. JavaScript code running in the Lambdas, what happened? So we realized, hey, let's just make the code smart. So if the code knows it's in development, just run it in the browser and we can debug it with browser debugging tools. If it's in, if it's in production, great, run it in Lambda. So it's great having lots of JavaScript runtimes where we can make those switches. Out of order messages, when we build things on-prem, we can go nuts tuning latencies and getting everything perfect so the message is received in just the right order. We had to put a 15-second read filter that allows the messages to arrive and then we can sort them out and make sure that we get things in the right order. it was a simple thing to do, but it really confused us when we first started. And then our firewalls use tags to be able to identify what things are allowed in and out. And so to access our on-prem infrastructure, we actually had to create an EC2 instance that would proxy those requests in and out to help with our network security layer. So there has been some friction and kind of weird stuff that we had to deal with as we went through this process. I think now that we're through it, things are moving a lot faster. Oops, going the wrong way. Okay, so what's next? So this is our digital supply chain we just talked about. Our analytics. The next thing is add more workflows, add our cloud master library so that we can keep those masters that we received in the cloud. Our cloud editing and versioning capability, and ultimately our ability to run some of our master control operations in a cloud context and originate channels directly from the cloud. So we got a lot of stuff to do, and so my big question to the room is, anyone want to work on this? If so, Chris Ferris, front row. He'll help you out. All right. Tiny bit of time for questions.
Sure. So while we're getting ready here, please remember to complete your evaluations. We really appreciate your feedback and some related sessions.
All right, and you guys know the drill. I encourage you guys to all come back, though, because that was a great handoff. The next session, we're going to have Discovery Channel up here to talk about their channel origination from the cloud. So kind of like we planned it. Hey, so real quick, if we have one question, two questions, we might be able to slip that in. Okay. Hey, everybody, a big round of applause. Thank you guys very much.